Redox titrations. This is the title of this lesson. A bag of road, this is the question. A bag of road salt used to melt ice and snow from roads contains a mixture of calcium chloride and sodium chloride. So mixture of these two species or two salts, calcium chloride and sodium chloride. So the weight of the sample is 2.765 gram of this mixture. Was analyzed by first converting all the calcium into calcium oxalate. So the calcium coming from calcium chloride, all of it converted into calcium oxalate. This was then dissolved in sulfuric acid and titrated with 0.100 mole decimeter per decimeter cubic potassium permanganate solution. The titration required 24.65 centimeter cubic of potassium permanganate solution and produced manganese +2, carbon dioxide gas and water. So we need to answer this 7 questions based on this information. First one, what would be observed at the equivalence point of the titration? So titration means we take a burette, add to it potassium permanganate, and as you know, potassium permanganate color is pink, and the concentration of it based on the given data, 0.1 molar or 0.1 mole per decimeter cubic. We used 24.65 centimeter cubic or milliliter to get the equivalence point, and the titration solution or the solution that titrated is calcium oxalate and sulfuric acid. So at the equivalent point, the solution changes from purple to colorless. Why? Because potassium permanganate is purple and the manganese ions are very pale pink, or you can say colorless. Next question. Write the half equation for the oxidation reaction starting with oxalate. So here oxalate, it gives carbon dioxide. So this is the oxidation reaction. So oxalate ions being oxidized to carbon dioxide. All elements are balanced, so only need to balance charge by adding electrons. So here at the reactant we have -2, so the product must be also -2. So this is why we added 2 electrons. So here -2 and reactant side -2. And this is oxidation because loss of electrons. The second half equation, we need to write the half equations for the reduction reaction. So permanganate give manganese. So first we need to balance the metal. After that we need to balance the oxygen. We have here 4 oxygen, so we have to add water, 4 water molecules here to balance the oxygen. After that, after balancing the oxygen, we need to balance the hydrogen. So we added 8 hydrogen here in the product side, so we need to add 8 H plus in the reactant side. Then balance the charge by adding electrons, and because it's reduction, we need to add electrons in the product, in the reactant side. So here we have 1 negative and 8 positive, so the total is 7 positive. And here we have 2 positive. This is why we need to add 5 electrons negative. So the total here will be 2 positive and in the product 2 positive. So this is the answer of question C. Then write the overall equation for the redox reaction. So because we use 2 electrons in equation B and 5 electrons in equation C. So we have to multiply B by 5 and C by 2. So the total electrons will be 10 in the 2 equations, because the number of electrons must be the same. And after that we can cancel them. 10 electrons released and 10 electrons gained, so can be cancelled with each other. And if we have water or H plus in the reactant and the product, also can be cancelled, but in that case we don't have. Then combine the 2 equations, and this is the answer. Then determine the number of moles of oxalate. So we need to write the equation again. 2 mole, based on the balanced equation, 2 mole of permanganate react with 5 mole of oxalate. So to calculate the number of moles of permanganate first, so number of moles equal concentration times volume. Concentration is 0.1 mole per decimeter cubic, and the volume is 24.65 centimeter cubic, but we need it in decimeter cubic, so we have to divide by 1000. And later decimeter cubic will be cancelled with decimeter minus 3, and the only unit left is mole at the end. And if you multiply that by that, it will give you 2.465 times 10 power minus 3. So based on the equation, we have 2 mole permanganate here react with 5 mole oxalate, and based on the calculation that we did, we used this number of moles of permanganate. So how many moles of oxalate will react in that case? So this times that divided by that. So cross multiplication. Again, this is unknown. In front of unknown, this one times 5 divided by 2. So it will give you 6.16 times 10 power minus 3 mole of oxalate. Next, deduce the number of moles of calcium in the original sample. Moles of calcium in original sample is 6.16 times 10 power minus 3. Why? Because the ratio of calcium ions to oxalate, so this is oxalate, not carboxylate, it should be oxalate ions, is 1 to 1. As you can see here, calcium oxalate is 1 calcium, 1 oxalate, and this is wrong. This should be oxalate. Okay, so if we have 6.16 times 10 power minus 3 oxalate, should be the same for calcium. What was the percentage by mass of calcium chloride in the road salt? So mass of calcium chloride equal number of moles times molar mass. Right? You know this equation or this law, because number of moles equal mass divided by molar mass. So just we rearranged the law. So mass of calcium chloride equals 6.16 times 10 power minus 3 moles, this number of moles of oxalate, of calcium chloride, sorry, times, this is the molar mass of calcium chloride, it will give you the mass of calcium chloride. But the sample mass was 2.765. That means the percentage of calcium chloride in this sample was 0.684 divided by the total mass that we used of the sample times 100 equal 24.7%. What about the rest? The rest was sodium chloride, the other salt. Another question. Alcohol levels in blood can be determined by a redox titration with potassium dichromate according to the following equation. And they give us the equation. We need the alcohol percentage in the blood by mass and describe the change in color that would be observed during the titration. Almost the same equation like the permanganate equation. Let's see the answer. So, to determine the alcohol percentage in the blood by mass, first we need to write the equation. Ethanol plus dichromate plus 16H plus give carbon dioxide plus chromium plus 3 plus 11 water. So in the burette we added potassium dichromate, the concentration 0.055 mole per decimeter cubic. This is the concentration given, and the volume 9.25 centimeter cubic, and the sample titrated is blood, 10 gram blood. So moles of potassium dichromate again equal C times V equal, this is the concentration times the volume, divide the volume by 1000, same like in the previous equation. To convert it into decimeter cubic, it will give you the number of moles. Then based on the equation, 2 dichromate react with 1 mole ethanol. Look, 1 mole ethanol here. So this is the number of moles calculated. How much moles ethanol in that case? Cross multiplication, this number times 1 divided by 2. So it will give us this number of moles of ethanol. Easy. The mass of ethanol, this should be C2H5OH. This oxygen is wrong here. This should be hydrogen. C2H5OH equal number of moles times molar mass of C2H5OH. Again, this is wrong. This should be hydrogen. So the number of moles we calculated times the molar mass of ethanol, 46.08 gram per mole, and this is the mass of ethanol. So the percentage of ethanol, again this should be C2H5OH by mass, equal the mass of ethanol divided by the total mass of blood, which is 10 gram sample, the one that we used for titration, times 100 equals 0.117%. Only ethanol in the blood. Describe the change in color that would be observed during the titration. So this is the equation again. Potassium dichromate is orange in color. Convert it into chromium plus 3, which is dark green. So the change will go from orange into green.